So welcome. This is Relations and Irrational Expressions, Lesson 1. Standard disclaimer, please make sure you're attending class because these are just kind of a rough outline of what's covered in class. They are not by any means the full lesson. So going with this, what we're talking about today is we're talking about rational expressions. Rational expressions, just so you're aware before I remove this, are essentially polynomial fractions. They're fractions with x in them. And to do that, you need to not only know factoring and how to work with the x's, but you also need to know fractions, which a lot of people have trouble with. So this whole lesson is all about just making sure you understand fractions and going through with that. Now, going through first off with fractions, here I've got a couple examples that are partially done. Reducing fractions. So you remember you've got to pull out a common factor of both the numerator and denominator. Now some of you will have just divided top and bottom by whatever the largest number you can see is, but I want to make sure you understand that what's going on really is you've looked and found a common factor of 4, and you may have divided by 4, however you do it, but really you're factoring. So you get 4 times 1 in the numerator, 4 times 2 in the denominator, and the 4's end up canceling out. These 4's here, they're common factors in both the numerator and denominator, so they cancel out and they leave you with the 1/2 that's left over. With this one here, 16 and 96, it's a little bit larger, so I just start thinking. Now you can do this in multiple steps. Some of you may see I think there's a 16 common. You may not have seen that, so you may go on in different steps. The first thing I would probably look at if I was having trouble is, well, they're both even, so I can divide both in top and bottom by 2. So I can factor out a 2 of both the 16 and the 96. So I did that. Factor out the 2, I get 8. Factor out the 2, I get 48, and the 2's cancel, so there we're good. But 8 over 48 still not done. So I say, well, what can I divide 8 and 48 by? What's a common factor between those two? And so one example is 4. So I pull out the 4 out of the 8 and I get 4 times 2. I pull 4 out of the 48 and I get 4 times 12. The 4's then cancel. And I look at the 2 and the 12 and I say, well, is that done? No, it's not. So I can pull out a 2. So to get 2 times 1 in the top and 2 times 6. 2 times 6 in the denominator. So I've got that, and so I reduce top and bottom by 2, and I get 1/6. Okay, provided I've done my math right here. And so I go through with that, and that's how I get an expression for that. I've reduced these fractions. Sorry, I just paused it again because I've been going through a whole bunch of kids coming in, so I apologize. With that one there, that's reducing fractions, so hopefully you remember that. We'll be reducing fractions repeatedly throughout this. Now, multiplying fractions. If you have to multiply a fractions, remember that you multiply the numerators, then you multiply the denominators, and then you reduce what's left. And that's what happens there. So if I look at something like 3/5 times 10 over 21, what I get is 3 times 10, well, that's 30. And I get 5 times 21, which is 105. Okay, so I get that. Now, that's all well and good. It is correct, but it's not reduced. So now I'd go and reduce that again. So I'd say, well, what do I have common in there? I have a 5 and a 3, so I have 15 common. So pull it out, 15 times 2. And in the bottom, I'm going to get 15, and it's going to be, I'm pretty certain it's 7. There are the 15s, they're the common factors. I can pull them out, and I'm going to get the 2/7. That's the final answer. So you can keep going and do this all you want. It doesn't really matter what happens. If I do something like 1/2 times 4/3, 4 times 1 is 4, 2 times 3 is 6. So I'd get 4/6. Then I start saying, well, how can I reduce that? There's a 2 common, so I'm going to pull that out. And I pull out the 2 in each case. The common factor of 2 cancels, and I end up with 2/3. Now I'm showing more work than I would if you were, looking at me doing multiplication of fractions. But nonetheless, I'm just trying to make sure you understand. If you see a shortcut, feel free to use a shortcut, provided you get the right answer. Okay? Going through with this, the one thing that kind of confuses people, if I do 6 times 4/15, okay, that is not a mixed fraction. It is not 6 and 4/15. It's 6 times 4/15. So in this case here I have to say, well, what do I do? And the biggest trick that we want everybody to remember is if a whole number is there, it's actually a fraction of 6 over 1. So you've got that. Now 6 times 4 is 24, and 1 times 15 is 15. And I look at that and I say, how can I reduce that? And I say, well, what can I do? I see a common factor of 3, so it's going to be 3 times 8 over 3 times 5. The 3's are going to cancel, and I'm going to get 8/5. Now I know that's an improper fraction. I know somewhere, probably in junior high, somebody harped at you repeatedly about, well, this would be 1 3/5. I don't use mixed fractions very often. They don't come up in rational expressions, so I'm going to ask you just to leave it as an improper fraction. As long as you can do the operations, then you've got the basics of what's going on. Now, when it comes to dividing, well, that's the next one you went to. And dividing fractions, it's the same as multiplying by the reciprocal. I remember when I was in junior high, and I know some of you probably have heard, you flip the second fraction. As long as you remember that the second fraction, the second part of this, sorry for bumping the microphone, the second part of this is the part that gets reciprocated or flipped, or however you want to talk about it. Then once you've done that reciprocal, you just multiply. So if I take an example like 3/5 divided by 6/15. Okay, in this case I've got these two fractions. I just have to remember the second one gets flipped, or I take the reciprocal of the second one, so it's 3/5 times 15/6. And now I just multiply just like I did before. So 3 times 15 is 45, 5 times 6 is 30, and then I've got 45/30ths, not reduced, so I'm going to say, what can I divide top and bottom by? I see a common factor of 5, so I've got 5 and 9, 5 and 6, the 5's cancel, so I get 9/6. That's still not reduced, so I'm going to divide top and bottom by 3, so that's going to be 3 times 3 in the top over 3 times 2 in the denominator, and I'm off the screen. The 3's cancel, and I'm going to end up with 3/2, and that is fully reduced. So you've got that. That's dividing fractions. Rational expressions, it's the same idea. If you're dividing rational expressions, as you'll see when we go to it, you just flip the second fraction. Once again, if I'm doing a whole number, something like 4/15 divided by 6, okay, I've got to remember that that's 6 over 1. So this is going to become, pardon me, 4/15 times 1 over 6. 4 times 1 is 4. 15 times 6 is 90. So I get that. Then once again I look to reduce it. I see a common factor of 2, so I'm going to pull it out. It's going to be 2 times 2 in the top, 2 times 45 in the denominator. The 2's cancel. I get 2/45, which can't be reduced any further. So that's my final answer. A lot of times too, when people start doing these things, they say, well, I got a fraction as an answer. Is that okay? Sure, it's okay. A fraction's a number too. So you just keep going. Now when it comes to restrictions, okay, restrictions are important. You can't divide by 0. You've been told this repeatedly. You cannot divide by 0. It means the second number in the division can never be 0. Okay, if the 0 is in the numerator, you can do it, but if the 0 is in the denominator, you can't. So if I look at this one, e.g., what is 5 divided by 0? Well, that is impossible. It cannot be done. It's empty set. What does it mean? Well, looking at a variety of different things really quickly, why can't you divide by 0? Just take a look at and see how it kind of goes crazy. If I do 6 divided by 3, what that essentially means is I have 6 dots and I want to make groups of 3. How many groups of 3 can I make? So if I tape 6 dots, how many groups of 3? 2 groups of 3. I can make 2 groups of 3, so the answer is 2. That's what this boils down to. If I do 6 divided by 1, how many groups of 1 can I make? Well, 6 dots. 1, 2, 3, 4, 5, 6. I know I'm using the same sketch. I can make 6 groups of 1, so I can make 6. If I do something like 6 divided by 0, now going with that same idea, I've got 6 dots, and I'll redo, there they are right there. How many groups of 0 can I make? Well, there's one. There's another one. Here's one that kind of looks a little squiggly. There's a bunch of little ones in here, and then little ones in between, and little more ones in between, and some of them overlap, and there's one over here, and I just drew one on your forehead, and there's a couple more. If you turn around and look at the floor beside you, there's like 1,000 there, and you know, I've got I'm in a room, so I'm drawing on the wall, and I could go, you know, take a look. And I'm driving to Calgary, and when I go to Chinook Center to the Lego store, I'm going to do one on each piece of Lego that's in the store, and there's so many there. Basically, what it means is, well, it's undefined. It can't be figured out. There are how many groups of 0? I can do an infinite number of groups of 0, and it still doesn't mean anything. I still can't define what it is. So it's undefined. It's empty set. This symbol, and we'll do this later too, it's like an O with a slash through it. Okay, that's empty set. It just means it can't be defined. So whenever you do these divisions by 0, that's what's going on. So if I have 5 divided by 0, it's empty set. If I have 17 divided by 0, it's empty set. The key thing is, though, you can have a 0 first. 0 divided by 6. Okay? 0 divided by 6. I have no dots. They're right here. You can't see them, but there's 0 dots there. How many groups of 6 can I make? Well, I can't. There's no dots. So I can't make a group of 6 out of them, so there are 0 possibilities. How many groups of 6? I can make 0 groups of 6. But you've got that idea. So that's restrictions. Now restrictions are very important. You just got to remember you can never divide by 0. And so as you're going through, we're going to start talking about these restrictions, because things end up you know, having some sorts of restrictions of x, because if I've got x in there, there are values that x can't be, because if x is those values, I'll have to divide by 0, which I know I'm not allowed to do. Other examples here just to keep in mind, look at this one. 7/5 divided by 0/4. So I look at that, and at the first glance, 7/5 divided by 0/4. 0/4 is an allowable fraction. There's nothing wrong with that fraction. But when I look at this one, I say, okay, I'm all set and ready to go. So it's 7/5 times 4/0. And at this point, this fraction doesn't make any sense. So this fraction doesn't mean anything. So at this fraction here, this is undefined. It's empty set. It's undefined. And so since part of it is undefined, if I can't say with certainty that this piece of this whole thing, and I can't describe what it is, I obviously can't describe the whole thing. So the whole thing ends up being undefined. Okay, and that's where you see what we're going to have later on when we start doing division of rational expressions. Is there's some weird stuff that happens with the restrictions, or the non-permissible values we sometimes call them, when I do divisions. There's just some weird things that happen. So looking at some other things I need to remember about fractions. Well, I don't have much more to go, but adding fractions. Okay, adding fractions, I need a common denominator. Somebody harped at you about that before. Common denominator, common denominator, common denominator. Sometimes it's easy. If I give you a common denominator, things are good. If I say 5/9 plus 3/9, the denominators are already the same. They're both ninths, so I'm going to add them together. Not that, but I'm going to add the fractions together. So 5 plus 3 is 8. You add the numerators, keep the denominator the same. Same with, you know, as long as the denominators are the same, we're all good. Everything's fine. It's the common denominator that causes the issue. Now, I need you to know that there's an infinite number of common denominators. You can use whichever one you want, but the lowest one makes it easiest. It's the least amount of work. Sometimes it takes a little bit to find the lowest common denominator, but once you get comfortable with it, the lowest common denominator is the quick and easiest one. So I can look at this. Now what I end up having to do is, if I take something like 1/3/7 plus 4/3, okay, I look at these and I say, well, the denominators aren't the same, so I need to find a common denominator. Those of you that have no trouble with fractions are looking at this, screaming at the screen, this is 21. If you have trouble with this, there's lots of ways to find the lowest common denominator. One way I sometimes do it is, if you don't see it, go through and look for lowest common multiple. So I'm going to take 7 and I'm going to take 3 and I'm just going to skip count for each one. It's 7, 14, then 7 more is 21, then 7 more is 28, then 7 more is 35, and so on and so forth. So I do that. Skip counting by 3's, it's 3, then 6, then 9, then 12, then 15, then 18, then 21, then 24, and then 27, and a whole bunch of you are yelling stop. Once I see that there's the same number in each list, same number in each skip count, that's my lowest common denominator. The first one I find is the lowest common denominator. If I keep this going, I'm going to find another one. There's no ifs, ands, or buts about it, and I'll find more and more and more and more and more. That's how you find the lowest common denominator. And what I have to ask myself is, how do I make this 7 21? Well, if I multiply it by 3, because it's the third number in that list, first, second, third, I can make it 21. And ditto here, to make that 3 21, it's the 1, 2, 3, 4, 5, 6, 7. So it's the seventh number there. So I'm going to multiply it by 7. But I can't just multiply parts by 3 and parts by 7. It changes the whole situation. So what I have to remember is the one thing I can multiply by without changing anything is 1. 5 times 1 is 1. 8 times 1 is 1. Negative 50 times 1 is negative 50. Did I say 8 times 1 is 1? I think I might have said that wrong, but 5 times 1 is 5. 8 times 1 is 8. Negative 50 times 1 is negative 50, so on and so forth. So if I multiply by 1, it doesn't change anything. So to make this 3 that's in the denominator 1 altogether, I'm going to put a 3 in the top. And then the 3 and the 3, they don't have to be there. They're 1. I'm multiplying by 1 by putting the same piece to the top and the bottom. Here, this 7, to make it 1, I'm going to put a 7 in the numerator, because whatever I do to the bottom, I have to do to the top. And now the 7 over 7 is 1. So I'm multiplying by 1. I am allowed to do that. So that's where that rule, whatever you do to the bottom, you have to do to the top, that many of you have heard, comes from. Okay, now I'm multiplying by 1. So now things are good. Now I've got a series of fraction multiplications, but I'm going to do that. Now it's 3 times 3 is 9. 3 times 7 is 21. Plus 4 times 7 is 28. Over 3 times 7 is 21. Now, I know both these fractions could be simplified, but I don't want to do that right now. I've just done all the work to make them common denominators. I could simplify them, and if I do, I'll end up with those two again. Same ones I started with. So I want to leave them as is. Now I've got a common denominator. I add the numerators. 9 plus 28 is going to be 37 over 21, and we're all said and done. Okay, you can have any sort of common denominator and it's still going to work. Okay, if you don't use the lowest, it won't be finished. Okay, you'll have more work to do, i.e. 1/6 plus 3/8. I'm looking for a common denominator. Some of you are saying, well, 3 times 7 is 21, so that's my common denominator. It always will be a common denominator. 6 and 8 times 6 times 8 is 48. 48 will be a common denominator. It's just not always the lowest. The lowest one is 24. If I make them both 24, I'm just going to put that over here. LCD is 24. Okay, I'm trying to make this 24. So to do that, I'm going to multiply by 4. Whatever I do to the bottom, I got to do to the top. To make this one 24, I'm going to multiply by 3. Whatever I do to the bottom, I have to do to the top. What I'm going to end with is 4 24ths plus 9 24ths. Now I can add the numerators. 4 plus 9 is 13. 24ths I reduce if necessary. I don't have to reduce this one. So all is said and done. These are fractions. Okay. Subtraction of fractions is the same basic idea. You have to get a common denominator. You absolutely have to get the common denominator. The only difference is, instead of adding the numerators and then keeping the denominator the same, you subtract the numerators and keep the denominator the same. If I do an example, e.g. 3/4 minus 1/2, I think of the common denominator. My lowest common denominator is 4. Okay, this one's already done, so I don't have to do anything to this guy. Lowest common denominator is 4. This guy here, I have to multiply the 2. Whatever I do to the bottom, I have to do to the top. I'm going to end up with 3/4 minus 2 times 1 is 2, 2 times 2 is 4, minus 2/4. I subtract the numerators because that's what I'm asking. 3 minus 2 is 1. Keep the denominator the same. All is well and good. Okay? If you get a negative, that's okay too. So if I look at this one, 1/6 minus 3/8. Okay, we just did this as a plus. We know that the common denominator, the LCD, is 24. Okay, I did skip counting. I can see that. Count by 6s, count by 8s, which number's in both lists? 24. So I'm going to multiply top and bottom here by 4, top and bottom here by 3. 4 times 1 is 4 24ths minus 9 24ths. Now I do the subtraction of the numerators, keep the denominator the same. 4 minus 9, it's negative 5 24ths. Can you have negative fractions? Sure you can. So there you go. This is just some fraction stuff. Now, there's going to be some practice in class. Please make sure that this makes sense. Please make sure you can do this. Otherwise, come for help and have a wonderful day. Bye.